T215 computer system. Which of the following standard RAID level should be used where maximum storage capacity is required, but data redundancy or fault tolerance is not required? Is it A, RAID 0, B, RAID 1, C, RAID 4, or D, RAID 6? What is RAID? RAID stands for Redundant Array of Independent Disks. It is a data storage visualization technology that combines multiple physical disk drives components into a single logical unit for the purposes of data redundancy, performance improvement, or both. Data is distributed across the drives in one of several ways, referred to as RAID levels, depending on the required level of redundancy and performance. So now let's look at some of the RAID levels. First of all, let's look at RAID 0. This provides data stripping, spreading out blocks of each file across multiple disk drives. However, this provides no redundancy of data. It offers the best performance, but does not deliver fault tolerance. If one drive fails, then all data in the array is lost. In RAID 1, we provide the opposite. This provides disk mirroring. This configuration consists of at least 2 drives that duplicate the storage of data. There is no stripping. In RAID 2, the configuration uses stripping across disks, with some disks storing error checking and error correction, or ECC information. This has no advantage over RAID 3 and is no longer used. So in RAID 3, this technique uses stripping, and it dedicates one drive to storing parity information. The embedded ECC information is used to detect errors. Data recovery is accomplished by calculating the information recorded on the other devices. In RAID 4, a commonly used implementation of RAID, the level uses large strips, which means you can read records from any single drive. This allows you to use overlapped I/O for read operations. If a data disk fails, the parity data is used to create a replacement disk. A disadvantage to level 4 is that the parity disk can create write bottlenecks. RAID 5. This level is based on block level stripping with parity. The parity information is stripped across each drive, allowing the array to function even if one drive failed. RAID 5 requires at least 3 disks, but it is often recommended to use at least 5 disks for performance reasons. This results in excellent performance and also good fault tolerance. RAID 6. This technique is similar to RAID 5 but includes a second parity scheme that is distributed across the drives in the array. The use of the additional parity allows the array to continue to function even if 2 disks fail simultaneously. RAID 6 arrays have higher cost per gigabyte and often have a slower write performance than RAID 5 arrays. By looking at all the RAID level explanation, we can see that the answer is therefore going to be A, RAID 0, is the correct answer according to the RAID standard levels. So here we can see our answer is A, as we mentioned on the previous slide, RAID 0. So here we've looked at what the different level of RAIDs mean and how they function, and what are the positives and negatives of some of these schemes.